is a very quick math question for walkthrough. And step one, what you gotta do when you got this question is enter your function into your calculator, and do that by pressing f of x, Jimmy button, ln x over x cubed. You find Jimmy button right here, you press Control Jimmy, which is this one right here. Okay, you do that, and to get the domain, you write enter solve f of x is smaller than infinity, comma x. And when you write all these functions like solve or zeros, you always gotta put x because that's a variable you're looking for. That's the thing you will get defined as. And to find solve, press menu free 1, which is menu free 1, right? And that's it. And then to find the infinity sign, you'll just have to press right where here near the letters. Okay, so find x-intercepts, you put in solve of f of x equals 0 comma x, get x equal 1, that's easy. And f of 0 is undefined, so there's no y-intercept. Okay, so cy, to find the vertical asymptote, if there's a function with top over bottom, you do bottom equals 0 to find the vertical asymptote, do x cubed equals 0 comma x. That's what you gotta put on your page as well as the calculator. And sorry, and then you get x equals 0, and then check this for a graph and table. It's kind of useful. Just do that as well and write it down as well. Do lim x tends to 0 from above, so tends to 0 from above of f of x. You get lim x by pressing menu 4, and then you get infinity sign again by pressing a little pi button, which is right here. And yeah, now to get y was the asymptote, you get lim x tends to infinity, right? And you get 0, so horizontal asymptote is 0, and you get lim again by pressing menu 4. It's good to remember all these combinations, but you could just as well just write it down somehow. Okay, now find and classify stationary points. Well, this is really quick and easy if you understand what you're doing. So we need to remember that stationary points are when f dash of x is equal to 0. And to get f dash of x on the calculator, we do d over dx of f of x on calculator, right? Okay, so the first, and to find 0s at any point, like if it's f dash dash of x or whatever, you do the zeros function. So for this step, we do zeros of f of x, it tends to a, so it just basically means what values when f dash of x is 0. That's all it does, this whole thing right here. You get an answer of each the third, and you store it into A, and how you store, you press Control and var right here. You can see it's stored right there. And then you get d by dx by pressing menu 4 get zeros by pressing menu 3 right? Okay, so we got the value, and now we have to check if it's a maximum or a minimum. So at max, f dash of x is negative because if it goes like that, the gradient is always decreasing, and at minimum it's always increasing, right? Okay, so at minimum it's positive. So to get that, you do d squared by dx squared function. So you enter d squared by dx squared of f of x where x equals a. So you just got to define where x equals a. You found a and defined it here. And remember, you store it into variable. Don't forget to always do that. Okay, so when you do that, you get your answer. You get a negative value, which means it's a maximum. So to get d squared by dx squared, you press the Jimmy button and find it on the far right, and the Jimmy button is this one right here. Okay, and to get the where sign, you press Control and equals right here. Okay, so now find the value, y value. You just write f of a, and you'll get each the minus 1 over 3, and then that's it. You're done for this one. And find and classify points of inflection. So all points of inflection are at f dash dash of x equal to 0. And to find the values at 0s, we use the zeros function, you know. So we just use zeros of, well, this just means when f dash dash of x equals 0 values, we get this whole thing. And then again, just like last time, we store it in a, and then we get this value of each of the 7 over 12. I think it's each of the 7 over 12 like that this time, but essentially you get zeros by pressing menu free 4, you get d squared by dx squared by Jimmy Button, and then on the right, and then we already know how to store is control var. Okay, so when we continue, we need to look for a sign change all the time. So we see what values we get for f dash dash of x if we add 0.01 and or minus 0.01. So, and this is important because if there's like that, if it's a min, right, the sign change never changes, always like clockwise, or in this case anti-clockwise. And for the point like that, we need to see it's first like anti-clockwise, no, first clockwise and then anti-clockwise. That's what we're looking for sign change. So yeah, we add that. So dx, so we find f dash dash of x when x is a plus a little bit and when x is minus a little bit. We find their difference, so it's a point of inflection. And because it was not also at f dash of x, it's non-stationary point of inflection, right? Because f dash of x shows where the stationary points, okay? So now we just find f of a of that point, and then you got your point. That's it, you're done. Complete the table. Well, first thing is x tends to 0 from above, tends to minus infinity, and you got it in ci, and it's domain limit as well as vertical asymptote. Don't forget both. And then don't forget the y-intercept, obviously, because I did forget it. So x is 1 and f of x is 0, right? And then you put in a max, you put in an s point, and don't forget just to convert those each of a something and each of some values to decimals, so you see which one's higher than the other. And then when x tends to plus infinity, f of x tends to 0 from above. I first wrote like to plus infinity or something, but that's not correct. Remember, we have a horizontal asymptote, so that's where it goes. To sketch and label, you first plot all the points from a table. Yeah, even those with E, whatever. You just gotta convert those into decimals and plot them on the graph. Go to graph mode, press menu 4-1, at least I will do that. Change how the graph looks, so it's just like on your page, like the coordinates, like from X and to Y. Just change those things, and then just sketch something close enough to that graph, and then I'll be fine. Just go through the points you've already plotted. Okay. Okay, so we know the tangent line goes through 0, so c equals y minus mx equals 0, so that's all we need to know. So you should know that m is calculated by d by dx of f of x, and when we have something equals to 0, we can use a zeros function, right? So we write zeros is y minus x m, well, that's the same as mx, right? Right here, that's the same thing. Comma x, because we always use this. When you use zeros, we always define what we're looking for. And then we sort in tray because we're going to use it later. And then just do f of a to find the y value of this point coordinate, and then that's it. Okay, so now we have our points. Now we need to find our tangent function. We know a variable is always x, right? So we can use this command called tangent line to just quickly find the line we need. So we need three properties in this thing. We need the expression, which is our function f of x, variable, which is x, and point, which is a, right? Variable means x always all the time. Okay, so we just put in tangent line of f of x comma a, and that's it. You get your answer. Okay, and to get tangent line, you press menu 4 and 9. Yeah, I'm pretty sure that's it. Okay, line S. So first thing is you have to rearrange your equation so it looks like something like y equals minus x over 100 plus 4 over 100, and now you can see that m is that, right? So f of x is that because that's how we find m, right? Or f of x plus 100 is equal to 0, and we got 0, we can use the zeros function, right? So we put that, all that plus 100 comma x, always comma x, right, goes to a. Never, always do a, never forget it, because otherwise you're gonna get stupid answers when you're gonna use a before and have not defined it, or use a from a previous answer. So you get two values, right? and then you got f of a for those two values, and then you get like y1 comma y2, and I just gotta put your answers in a page like x1 comma x2 and y1 and x2 comma y2, and that's it. Okay, so now you gotta use tangent line equation again to find those two lines. So you just gotta do the same thing. You just do tangent line of f of x comma a. You get two equations, just copy down on the answer sheet. And yeah, now you just gotta have another g of x equation. So you need to find the intersection points where f of x is equal to g of x. So we know that f of x minus g of x is 0, right? So we can use the zeros function. We find the values, and then we just substituted them, and it's ln 3 over 27 both times. And you can use the factor function to make it easier, so we just do factor of 1 to t, right, of f of x dx, and then you just got like minus 4t plus t squared. Just gotta rearrange it so it's t squared plus 4t plus some number like 8 over whatever 4t squared. Anyway, just rearrange it so it looks nicely. Um, and for this one, you just get 1/4 as the answer. So all you write is integral of 1 to infinity, and you get infinity by pressing pi button and then choosing it. And you actually find the integral. I think you just press Jimmy and it's gonna be there, or you could just find it from menu for something. I think it's menu for free, but I'm not sure. Don't trust me on that. I think it's menu for free for the integral sign. So yeah, that's it. I hope it helped at least a little bit. Yeah, have fun on your exam.